What's up guys, this is Massey. Welcome to another video. In this video I want to talk about geometric sequences and I'm gonna show you some examples. Sequence that has the same ratio, which is also called the common ratio between any pair of consecutive terms, is called geometric sequence. And the general formula for geometric sequence is like this: Tn equals to a times r to the power of n minus 1. We had arithmetic sequences before, and I had many different videos in this channel. So in arithmetic sequences we are looking for differences, but in geometric sequences we are looking for ratio. So we need to find out if there is a constant ratio. It means that we are dealing with a geometric sequence. For example, the question is, determine which sequences are geometric. If so, state the common ratio. So instead of common difference, we have common ratio. First one: 1, 3, 9, 27, 81, 243, and so on. You're gonna say R is 3 over 1, 9 over 3, 27 over 9, 81 over 27, 243 over 81. All of them is 3. So you're gonna say yes, it is a geometric sequence. What about if you have 1, negative 3, 9, negative 27, 81, negative 243, and so on? You're going to say R is negative 3 over 1, 9 over negative 3, negative 27 over 9, 81 over negative 27, negative 243 over 81. That's going to be negative 3. So this is the common ratio. Next example. 5, negative 15, positive 45, minus 135, and so on. You're going to say negative 15 over 5 equals to 45 over negative 15 equals to negative 135 over 45. That's all going to be equal to negative 3. So that's the common ratio is negative 3, and this is a geometric sequence. Next example: 1024, 512, 256, 128, 64, 32, 16, 8, 4, 2, 1, half, 1 over 4, 1 over 8, and so on. R is 1 over 2, because 512 divided by 1024 is half. Same thing here, 256 divided by 512, and so on. So here again, we are dealing with a common ratio, which is 1 over 2, and this is a geometric sequence. Next example: 9, 36, 144, and so on. I'm going to say R 36 divided by 9 equals to 144 divided by 36. That's going to be equal to 4. So you're going to say yes, this is a geometric sequence. Next example: 1, negative 5, 25, negative 125, positive 625, and so on. Here the ratio is negative 5 over 1, 25 over negative 5, negative 125 over 25, 625 over negative 125. It's going to be negative 5. This is the common ratio. And that's why we are dealing with an geometric sequence. Next, 2, 8, 16, 64, 128. 8 divided by 2 is 4, 16 divided by 8 is 2, 64 divided by 16 is 4, 128 divided by 64 is 2. So you don't have common ratio. No common ratio. Therefore, no geometric sequence. Next, 1, negative 1, 1, negative 1, negative 1, positive 1, negative 1, and so on. So if you divide them, you're going to get negative 1. So R is negative 1. It's constant for all of them. It's the common ratio. Therefore, it is a geometric sequence. Next, negative 3, negative 15, negative 45, negative 135. So R is negative 15 over negative 3 is 5. Negative 45 over negative 15 is 3. Negative 135 over negative 45 is 3. So that's not a geometric sequence. Next, 0.1, 0.01, 0.001, 0.0001, and so on. What about here? I'm going to say yes, because R is 0.1. 0.01 divided by 0.1 is going to be 0.1, and so on. So this is the common ratio. Therefore, this is a geometric sequence. Next question, and this is going to be the last one. Negative 2, negative 10, negative 50, negative 250, and so on. Ratio is negative 10 over negative 2, which is 5, and that's common for the rest of it. So we're going to say yes, this is a geometric sequence. So that's how we find out geometric sequence. I hope you enjoyed this video. Please leave me a comment if you have any question. Thank you for watching and have a great day.